In a room, consider that there is a book placed on a table. How can we determine the position of the book in the room? Let us assume the position of the book in the room as P. If we have to determine position P, we need to know the perpendicular distance of P from at least two of the room's walls and also its height from the ground. As the distances of other two walls and ceiling from the book are dependent on these values. Thus, point P is a triplet, say XYZ, where X, Y and Z are the distances from the two walls and the height from the ground, respectively. Next, how do we determine the distance between two such points? Let A, X1, Y1, Z1 and B, X2, Y2, Z2 be the 2 points in space. We know that through a given point we can draw a plane parallel to any coordinate plane. Let A' be a plane containing point A, X1, Y1, Z1 and parallel to the XY plane. Now, draw a perpendicular from point B onto plane A'. Let this perpendicular meet plane A' at point D. Then the coordinates of D are X2, Y2, Z1. Consider another point C in A' plane such that CD is parallel to x-axis and AC parallel to y-axis. A right-angled triangle ACD is formed in plane A'. From the figure, AC is equal to delta y, that is y2 minus y1, and CD is equal to delta x, which is equal to x2 minus x1. By Pythagoras theorem, we know that AD is equal to square root of the sum of the squares of delta x and delta y. Now, join AB. This forms a right-angled triangle ADB. Since BD is parallel to z-axis, we have BD equal to delta z, which is equal to z2 minus z1. By using Pythagoras theorem, we get AB equal to the square root of the sum of squares of the two sides AD and BD, which is equal to the square root of the sum of the squares of delta x, delta y and delta z. Thus, we conclude that the distance of 2 points x1, y1, z1 and x2, y2, z2 in space can be given by the expression shown. Find the distance between the points 6, 4, 2 and 3, 2, 7. The distance between the 2 points is given by the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. By substituting the values in the formula and solving, we get the distance between the two given points as square root of 38. Find the value of y if the distance between points P 4 minus 2 15 and Q 1 y 3 is 13. The distance between the 2 points is given by the square root of the sum of the squares x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. We know that the distance between points P and Q is equal to 13. By substituting the values in the formula and solving, get the value of y as 2 or minus 6. The distance between 2 points x1, y1, z1 and x2, y2, z2 in space is given by the square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square.